Hello everyone and welcome back to another Shsat review video. Today I'm going to be reviewing some 9th grade sample questions from the 2020 Shsat Student Handbook. Link will be in the description. We're going to start off with page 221, starting with number 1. A function is given on the coordinate plane. The function is linear. What is the y value for x is equal to -4? Okay, so we're given linear, so we can plug it into the formula y equals mx plus b. And we're also given 2 points, so we can find m, and we also know when our line intercepts the y-axis, so we are also given b. So let's solve for them. So in order to find the slope, we have to do y1 minus y2 over x1 minus x2. So we'll go ahead and do that. This is our y1, this is our y2, so 3 minus 1 over our x1 and our x2. So 1 minus 0, that's going to be 2 over 1, which is equal to 2. So now we're given with the formula y equals 2x plus b. Now we have to find our y-intercept. Well, look, this line passes through the y-axis, and this point is exactly when it intercepts that. And if you look at that point, our x is 0, but our y is 1, which means our y-intercept is 1. So now we can write the formula y equals 2x plus 1. Now we can just plug in the formula for x is equal to -4. So we'll do y is equal to 2 times -4 plus 1. Y is equal to -8 plus 1. Y is equal to -7. Which is the answer. Remember, y equals mx plus b. Moving on, we have a system of equation. We have y equals 3 over 2x minus 1, and x plus 2y is equal to 6. So it'll be a real big hassle trying to solve and plug in values. So what we can do is we can put both of these in terms of y, and then make them equal to each other. So I'll get into this later. So first step, we want to make everything into y. So we can just subtract x from this side. Subtract it from this side. Now we have 2y is equal to 6 minus x. Divide by 2. We're given y is equal to 3 minus x over 2. Or, since we're going to make it equal to each other, we can literally just write 6 minus x over 2. And that's the y value for this formula, and this is already in terms of y. So since y is equal to y, we can just write that 3 over 2x minus 1 is equal to 6 minus x over 2. Because this entire formula is equal to y, and this entire formula is equal to y. Y is equal to y, so technically we can write their true expressions equal to each other and solve for x. So in order to solve for x, we'll multiply both sides by 2. This denominator and this denominator cancel. This denominator cancel. Where we are left with 3x minus 2 is equal to 6 minus x. We add an x on this side. We are left with 4x. We added 2 on this side. 4x is equal to 8. Divide by 4, we have x is equal to 2. Essentially, instead of destroying our mind and wasting time on solving for x and plugging x in and all that, we made both of these into y, and then we turned both of these into terms of y, and then we put those expressions equal to each other because y is equal to y. Next, what is the difference in x values from the graph from where the function first begins decreasing to where it begins decreasing again? So if we look at it from here to here, it's increasing, and then at this point everything just goes downwards. So our first point will be 2, because this is our x-axis. X value is 2 for this point. So then we drop down. Then on this point is going to signify when it's going to start rising again. So we're going to start rising. Right here we top off, and after this point we go downhill again. So our second point is 12. 12 minus 2 is equal to 0. Sorry, no, it is not equal to 0. It's equal to 10. So our answer has to be 10. This is really easy. Don't get confused. Actually draw it out, play it out, see what happens. Number 4. The diagram shows a pole connected to a wall at a 90-degree angle. 17-foot wire is attached to the pole at 8 feet out from the wall. How many feet above the pole is the wire attached to the wall? Okay, so look at this. We know that this is a right angle, and we know that this entire thing is a triangle. So we can just and we know, since it's a triangle with a right angle, it's a right triangle. So we can use the Pythagorean theorem, which is a squared plus b squared equals c squared. Now we are given our b, which is 8, but we are missing our a, which is the height of the wall. So we can just finagle this formula to be in terms of a. So we have a squared is equal to 8 squared. So nope, that is wrong. I'm sorry, guys. So we're gonna be left with a squared plus 8 squared, because 8 is our b, is equal to 17 squared. That's a squared plus 64 is equal to, let me calculate this real quick, I was not prepared. 17 squared, 289. 289. Next we can subtract 64 from both sides. 289 minus 64, that gives you 225. A squared is equal to 225. Square root both sides. The square root of 225 is going to be 15. And if you square root a square, they cancel out, so A is equal to 15, which is our height. Pretty simple, remember your formulas. Number 5. A researcher recorded the pollution data that measured the presence of potassium nitrates in some lakes. The scatter plot shows the data. The scatter plot shows the data. Which statement describes the data shown in the graph? Okay, so let's just look at it right here. The data shows a nonlinear association. So, guys, what is linear? Fellas, what's linear? So a linear is when two axes, so preferably the x and the y axes, relate to each other. So this can be linear, or this can be linear, or this can be linear. Essentially, whenever a group of points kind of show that the x and y are related. Is that apparent here? Well, think. The more we go, the more potassium we add, the more nitrates we have. Because eventually we have the amount of nitrates found in 0.5. So the amount of nitrates before 0.5 milligrams of potassium is going to be less than the amount of nitrates found after 1.5 milligrams, which means that there is an association. The more potassium milligrams per liter, the more nitrates there will be in milligrams per liter. So yes, there is a linear association. The more x, the more y, and it kind of goes like this, up. Okay, so A cannot be right. Now B, the data shows multiple outliers. Well, does it? Because what is an outlier? An outlier is an extreme part of a data set. So if we had a set of 1, 2, 5, 7, 6, and we had 100 and 0.001, 100 and 0.01 would be outliers because they relate absolutely nothing to this set. So an outlier here would be 0 milligrams of nitrates in 1.5 milligrams of potassium, or 24 milligrams of nitrate in 0 grams of potassium and whatnot. So all of these points would be considered outliers, but they really aren't. All of these points are fairly close to each other, and they're fairly close, and you can essentially draw a line between them. So I don't think there are any outliers. And if you really want to check, you can kind of draw a line. It's called the line of best fit. Essentially, you should have an equal number of points on this side to this side. Now, this isn't really precise, but you can essentially see that they're all fairly close to the line that we drew. So no, there are no outliers. Next, the data shows a positive association. Well, yeah, it does show a positive association. The more potassium you get, the more nitrates you get. So that could definitely be an option. And the data shows a negative association. That's the complete opposite. That would be that would mean that our line would go down like that, which is false. Negative association would mean that the more potassium you have, the less nitrates you have, and the less potassium you have, the less potassium you have, the less nitrates you'll have, which is the opposite here. So the answer has to be C. Okay, number 6. How much greater is 1.8 times 10 to the power of 26 than 7.3 times 10 to the power of 5? Well, the wording may confuse you, but don't let it confuse you. They're asking how much greater, not how many times greater, not how many greater. So since it's not how many greater, or how more greater, I guess, much greater essentially is asking us to subtract both of them. All right, many greater would mean that we have to divide them. So keep that in mind. So now we know what we're going to do. We have to do 1.8 times 10 to the power of 6 minus 7.3 times 10 to the power of 5. And whenever we're working with exponents, when we're working with exponents, these have to be the same in order for us to subtract it. So we have to turn 1.8 times 10 to the power of 6 into 5. Or we can turn 7.3 times 10 to the power of 5 into the power of 6. I think it'll be easier to turn this into the power of 5. So if it's in the power of 5 and we're losing our exponent, we're going to the right, and it's essentially turning bigger. So since we're moving from 6 to 5, we're only moving the decimal place 1 point to the right. So now we're left with 18 times 10 to the power of 5 minus 7.3 times 10 to the power of 5. Since they're the same, they have the same exponent value, we can subtract them. We can eliminate our exponents because we're not going to look at them. And then we could just do 18 minus 7.3, which gives us 1.07, I think. Let me look at that right now. 18 minus 7.3 gives you sorry, this was wrong. It gives you 10.7. Now, notice how this 13 and 13 are irrelevant to this. We have an option of to the power of 6 and to the power of 5. And this is because when you have when something is in scientific notation, the number has to be between 1 and 10. 10.7 is greater than 10, so we have to actually reduce this and go and move the place 1 in. So if our number reduced moving right, it's going to increase moving left. So if we want to move this to the left, it's going to have to be 1.07 times 10 to the power of 6, which is C. So we never got rid of this 5. We just moved it to the side while we calculated it. And then we found out our answer was greater than 10, so we brought it back, and we moved 1 to the left, which means we had to add 1. So whenever moving to the left, you add. Whenever moving to the right, you subtract. So yeah, don't get confused on that. How is 0.6 for repeating times 0.2 repeating written as a fraction in simplest form? Well, you should know that anything over 9 is going to be infinitely repeating. So 6 over 9 is going to equal to 0.6 infinitely repeating. And 2 over 9 is going to equal to 0.2 infinitely repeating. And it applies for anything. 3 over 9 is going to be 3 infinitely repeating. And 10 over 99 is just going to be 0.1 repeating over and over again. So, it applies to everything. So we have that. Now we can just literally convert this to over 9. So we already did 6 over 9 times 2 over 9. That's going to give us 12 over 81, which when we divide by 3 and divide by 3, we get 4 over 27, which is our answer. This is a really important trick. Anything over 9 repeats infinitely, so don't forget that. Number 8. 2x minus 6 is equal to 8y minus 10, and x is greater than 5. What is the least possible integer value of y? Well, think about it. Whatever our x value is, we're going to have to subtract 6 from it, and then we're going to have to divide it by 8. So our rule when dividing is the smaller the number you're dividing, the smaller your answer is going to be. So for example, 10 divided by 8 is going to be smaller than 20 divided by 8. So whatever we do, we want our eventual number to be the smallest. And in order for it to be the smallest, x has to be 6. Because look, if x is 6, we're left with 12 minus 6 plus 10 divided by 8. But if it would be 7, we're left with 14 minus 6 plus 10, which would be a greater number. And the greater the number, the greater the dividing number, the bigger the number is going to be, which gives us the opposite of we want. We want the smallest number. So x has to be 6, which is the smallest possible number it can be. So plug it in. We do 2 times 6 minus 6 is equal to 8y minus 10. We do 12 minus 6 plus 10 is equal to 8y. So we get 16 is equal to 8y. Divide by 8 on both sides, we get y equals 2. So the smallest value of y would be 2. Always remember that rule and test it out before you do it. Plug in some hypothetical numbers and figure out your own rule. Will a larger x yield a smaller number, or will a smaller x yield a larger number? So always think about that before you do these problems. A data set relates a car's average gas mileage, y, in miles per gallon to its engine size, x, in liters. The equation for the line of best fit is y equals negative 3.25x plus 34.5. What is the meaning of the slope of the line as it relates to the mileage and engine size? Mileage and engine size. Okay. So, well, we have this formula. And essentially it calculates it to give us, okay, so it gives us to its engine size x. So this is its engine size, and this is its mileage. So we know our answer has to relate to engine size. So yeah, now that we have that in place, we can look through our answers. So for each decrease of 1 liter in engine size, the gas mileage is increased by 3.25 mpg. Well, is it? If our x is 1, that would mean that we're adding negative 3.25 plus 34.5, which gives a smaller gas mileage. So no, that's wrong. Actually, the gas mileage is decreased. Oh, wait, never mind. This can be this can be actually correct, because our gas mileage isn't decreasing every 1 size in liters. So for every increase in 1, wait a minute. Okay, disregard what I said. Sorry, I'm all over the place. Okay, so notice the key detail is for every decrease in 1 liter engine size, the gas mileage is decreased. Well, no. If our x is 2, that means we'll eventually have to do 6.5, negative 6.5 plus 34.5, which decreases our engine size. But if it was 1, we'd have to do negative 3.25 plus 34.5, which would actually be, it'll continue to decrease it, but decrease it less. So no. If anything, it's increased. For every increase in x, our gas mileage will go down. For every decrease in x, it will go up. So it has to be B. And then right here, for every increase in 1 mile per gas and gas mileage, the engine size decreases in 1 liter. That's dumb, because y is our mileage. And for this is the same thing, y is our mileage. So for here, just make sure to label, find out where your x and y is, and make a relationship between them and see if it's actually correct or not. See, I almost made a mistake, but I corrected my mistake right here. Always plug in numbers for these. Alright, number 10. On Saturday, the temperature changed at a constant rate from 2 a.m. to 2 p.m. At 4 a.m., the temperature was 47 degrees Fahrenheit. At 10 a.m., the temperature was 32 degrees Fahrenheit. What is the temperature at 2 a.m. on Saturday? Okay, so the temperature from 2 a.m. and 2 p.m. changed at a constant rate, so constant. At 4 a.m., the temperature was 47. and at 10 a.m. it was 32. So from 4 a.m. to 10 a.m. passed 6 hours. So 47 minus 32, that's 5. So in 6 hours, we dropped by 15. Now we can make our rate out of this, because remember, from here to here is constant. So whatever our rate for a 15 decrease over 6 hours will stick throughout everything. So we do that. 15 divided by 6 means that our temperature drops by 2.5 Fahrenheit every hour. So if the temperature was 40, oh wait a minute, if the temperature was 47 at 4 a.m., 2 a.m., and we want to know 2 a.m., 2 a.m. is 2 hours before that. So we'll do 2.5 times 2, and we know that there's a 5-degree change between 4 a.m. and 2 a.m. Now, notice how from 4 a.m. to 10 a.m. it's decreasing. So if you want to go back in time, you actually have to increase it. So what we're going to end up doing is adding 5 to 47, which gives us 52 degrees Fahrenheit, which is our answer. So always read carefully. The keyword here was constant rate. And number 11. Mn is rotated 90 degrees clockwise about the origin. What is the coordinate of n prime? Okay, so you should know that the rule of a 90-degree clockwise rotation is x comma y, and then it turns to y comma negative x. So n regular is going to be 0. Sorry, it's going to be y is 0, so it's going to be 1 comma 0, because we go 1 here and 0 because we're still at level. 1 comma 0, and this is our x and this is our y, and they're going to switch places, so it's going to be 0 comma negative 1, which is C. Oh, right, yeah, it's C. And then number 12 and 13. The diagram above ST NM and PQRM are rectangles on point S. Sorry, and point S is on RM. What is the length of RT in centimeters? Okay. So we find RT, and we know that this is a right triangle because it's two rectangles being combined together, which means they have to form a right triangle. So automatically we can use Pythagorean theorem. We know that ST is equal to 8, so we have one leg. And then we have to do a little bit of algebra to solve this. So we know all the way from here to here is going to be 10, but we know that this is 2. So in order to find our next leg, which is RS, we're going to have to subtract 10 by 2. We're going to have to take this segment away, which is 2. So 10 minus 2 is 8. We'll do 8 squared plus 8 squared is equal to c squared, because this is a Pythagorean theorem. That's 64 plus 64 is equal to c squared. That's 128 is equal to c squared. Then we have to do radical 128, which is D, our answer. Okay, so if we read this again, in the equation above shown below, in the equation shown above, y is greater than 0, and n is greater than or equal to 0. What value of x will result in the least possible of n? Value of n. So the least possible value of n is greater than or equal to 0. So the least possible value of n is going to be 0. So 0 is equal to radical 6 plus y plus, 0 is equal to radical y plus 2x minus 1 squared. Now notice that we have a square here, which means that both of them cancel out. So we get y is equal to, 0 is equal to y plus 2x minus 1. We get 1 is equal to y plus 2x. That means that y has to be equal to 1, and that means that x has to be equal to 1 over 2, which is D. That is the review for today. I hope you all enjoyed. I will not be posting tomorrow, because I will not be feeling well. Like, comment, and subscribe, and have a nice day.